All right, the first law we are going to look at is Boyle's law. Boyle's law. So Boyle's law states that the pressure of a fixed mass of a gas is inversely proportional to its volume, provided that the temperature is kept constant. So it's important you memorize this definition for Boyle's law. Okay, Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to its volume, provided that the temperature is constant. So look at the ways we can represent them. P, pressure is inversely proportional to volume. Okay, that's inverse. Or PV, by the time V comes over, it becomes a constant, equals constant. Graphically, as pressure is increasing, the volume is decreasing. Okay, so you can see this is the highest. This point has got to be the highest point on the pressure axis. Okay, so this is the highest point to the lowest point on the volume axis. So as pressure is inversely proportional to volume, as volume is increasing, the pressure is decreasing. So it's an inverse relationship. Boyle's law. So this is the graphical representation. It's important to know the graphical representation. Okay, or if you invert a volume, it becomes a straight line. Alright guys, let's move on to the next law. Okay, I'll run through the laws before we do an example question. Okay, so Charles's law relates volume and absolute temperature. It says the volume of a fixed mass of gas, your amount and your pressure remain constant. So we're just relating the properties of volume and absolute temperature. It says they are directly proportional. So volume is directly proportional to absolute temperature. Volume becomes kT. So by the time you cross multiply, you have V over T is constant. Remember, absolute temperature is temperature in Kelvin. Okay, so that is volume is directly proportional to temperature. That's Charles' law. Now graphically, look at this graph. This graph shows us Charles's law, or represents Charles's law. So you see, as temperature is increasing from 0 to like that, as the temperature is increasing on the horizontal axis, the volume is also increasing. This is the Charles's law representation on the Celsius scale. Why this one is the Charles's law representation on the Kelvin scale. Remember, Kelvin scale is the absolute temperature. Okay, that is why 0. That's why it doesn't cut through the volume axis like in the Celsius scale. So this is just absolute scale. So this is what we use in our calculations. All right, guys, let's talk about the Gay-Lussac's law. The Gay-Lussac's law is also known as the pressure law. The Gay-Lussac's law states that the pressure of a fixed mass of gas, you see that fixed mass of gas is always coming up, okay, at constant volume is proportional to the absolute temperature of the gas. Okay, so pressure is directly proportional to absolute temperature. Okay, so that is it can be represented as P1 over T1 is equal to P2 over T2. You know, there's a little mathematics right there. So get to know the definition and the way it's represented mathematically. So we can bring all these laws and equations together in the general gas law. So the general gas law combines, also known as the combined gas law. So by the time you combine Boyle's law, Charles's law, and Gay-Lussac's law, okay, mathematically this is Boyle's law. P1 V1 is equal to P2 V2 is equal to like so on and so forth. Charles's law is V1 over T1 is equal to V2 over T2. And then Gay-Lussac's law is P1 over T1 is equal to P2 over T2. Bring all these three together. You can combine them to have P1 V1 over T1 is equal to P2 V2 over T2. This is known as the general gas law or the general gas equation.